Okay, thank you for the introduction. What we're going to talk today about is, I know it's a topic that many people are very interested in because there are sort of some early practices, but not many really started to adopt CICD for machine learning using traditional tools. So what I'm going to show is how we're doing it with different customers and our open source project called MLRun and sort of lesson learns. With hopefully we'll get to some demo at the end. So without further ado, let's first understand the challenge that we're facing. The problem is most organizations still treat machine learning as a sort of a research project. You develop machine learning models, you test them locally, etc. You may apply them to some endpoints behind some HTTP endpoints or something. But really, in order to take full advantage of machine learning, you need to deploy machine learning as part of a business application. A recommendation engine, fraud analysis or detection, healthcare, there are many use cases, and financial use cases and so on. But for that, we need to build full production pipelines that work with live data that is extracted dynamically from databases, from streams, from endpoints. We need to process data at scale. We need to be able to retrain models, redeploy models on a rolling fashion, and so on. We need to monitor everything and be able to create feedback loop, figure out when our models don't perform or don't behave. And that requires a lot of engineering. That is not something you're doing on your notebook. Most organizations still see the machine learning effort as something like that in this slide. So essentially taking a data set from a source, whether it's object storage or data lake or data warehouses, creating some extraction of data from sort of something which is not really online source, running some data preparation. Once you've done the data preparation, you run training, sometimes in your notebook, sometimes using a managed service like an AutoML managed service, and then you evaluate your model. If you're sort of more advanced, you take your model, you put it behind some HTTP address, and other people can use it. It's still a very siloed approach where the data science flow starts with extracting static data and eventually producing a model and putting it someplace. In reality, this doesn't really work. We can't just take something in a notebook and productize it. We need to process data at scale. We need retraining in an automated fashion. Every time we change the code, every time the data changes, we need to redeploy models. So we need to take everything and make it containerized. We can't just use notebooks in production unless some of you think it's a valid approach. So what we need in production is something more like this. This is really where things get complicated. We don't just put some notebooks and run them inside a container or something. We have many different components in the production application. We have the sort of the training silo where we do the data preparation, we run the training sometimes using horizontal scaling, we run evaluation, we may do extra work on the models, transform them, compress them, optimize them, and so on. We may want to deploy the model and test the model as part of a real deployment, as a real endpoint. We may have different tools for orchestrating. So now it becomes a lot more challenging. We need DevOps or ML engineers. We need people to take the code and turn it into containers. We need to change our code to run as something that, when something fails, we have logs and telemetry data. So that's the first engineering effort. But this is just the first effort, because even for the serving, we can't just take a model and put it behind an endpoint. Usually the data will arrive in some unstructured way, like we have a JSON structure with all sorts of user data, and we need to contextualize it and enrich it with other user features and build a vector and then serve the vector into the model. And then once the model is serving, we need to apply some action. The model is telling us there's going to be a failure. We need to do something with that indication and throw a message to a database, to a message queue, and so on. So someone needs to build an online application that takes the model just as one part and the data as another part, and some other business logic and action logic. And this is just, again, the second silo. And the third silo is doing the monitoring, because we need to be able to monitor our model in production to see if the accuracy is okay, if there's no drift, and so on. And in order to do that, we have to take data from the production aspects, from the serving engine that intercepted new features and responded. But we also need to compare that data with data from the training. So now we also need to make sure that everything is synchronized, the data from the training, the data from the serving, the data from the analysis of the features, and based on that, issue alerts and let someone do something with those alerts. For example, retrain the model, change weights of an ensemble, and so on. And all of that is just one portion of the problem. Really, the biggest problem is generating the features or generating the data for the training and the serving portion and the statistical monitoring of those features. So we need to build pipelines, with Spark or Flink or any other tools. In many cases, some glue logic, custom logic that intercept our custom structures and transform them into something, a table or some streams. So all of that is a huge amount of work. It's it could take organizations even a year from some projects that we were engaged with. And the problem is that all those arrows are glue logic that someone needs to write, and they're not really standardized because it's all siloed of different people, different teams that work sometimes in synchronization, but many times they're not really synchronized and they're using different frameworks, different platforms, and that's a real headache. So if you think about your machine learning journey as just, okay, how am I going to train my model and serve it behind an endpoint, you will figure out eventually that building a real application or taking real advantage of machine learning requires building all of those. This is where many organizations sort of get stuck. So our goal is to try and see how we turn this thing, which is sort of a mess, very manual, to something automated, something continuous, and applying modern technologies and CICD approach to it. Just before we continue, what are those things that we need to do when we build a service? For each one of those components, what do we need to do? So just, it's not just taking a code and put it in a container. We need to take the code, put it in a container, put packages, run unit testing, have scripts built into it. Then we need to think about scaling out. If we want to take that data that we're processing or the model that we're serving or the data that we're training on, we need to think about horizontal scaling, or how am I going to deal with production data, which is massive. It's not necessarily a few megabytes of a CSV file. It could be gigabytes and terabytes. So we need to be able to scale out our workloads. And then we also need to think about performance, because eventually, if you're serving a model and you need to do recommendations for an online HTTP application, you have to respond within a set of few milliseconds. Okay, you can't just run some bad job query on your SQL and get the response, and 2 minutes out you're going to get a response. We have to apply techniques to make things efficient. So we need engineering efforts to create parallelism and sometimes add GPUs for deep learning and tune our queries and apply different methods of analyzing data as it flows instead of batch analysis. And this is only the first part. We also need to think about instrumentation, logging, monitoring, versioning, security, and applying automation to all the flow, CICD workflows, rolling upgrades, A/B testing, etc. So the efforts where people start, they say they're very optimistic initially. Yeah, we're going to finish everything in a couple of weeks, but eventually they see that there's so much work in turning some projects and each component in the project into a production artifact. It's a very big effort. So what we've done is a lot of automation to essentially do all of those things that you see here in a more automated way. So this way you can cut time to production significantly. So the first problem we want to address is all those silos that we discussed. Lack of the need to build glue logic for everything, the need to work across teams that are sort of not synchronized. Instead of thinking about each silos, and each silos have sort of the interactive part of developing and then the production part of running things, and then separating it to silos, we have sort of a different concept. Let's think about production first. Let's put all the production things that have to work in containers and online, etc. let's make them work together as sort of a more of a holistic approach. Let's make them glueless. So when I'm preparing features, I train on those features, I build models of those features without writing a single line of code, and make them scalable and performing. So this is the approach is essentially breaking the machine learning problem to 4 different main components. The first component is the feature store. The feature store is about taking data from different sources, transforming those sources, building aggregates and joins and other things to make those this raw data, turn it into a meaningful feature that we can use in production, and then take that and serve it to different applications, whether it's training jobs. So we need to snapshot and create sort of a batch data set that will be used for the training. If it's an online workload like a real-time serving, we need an online API that within a millisecond or so we can respond with the relevant data. We also need the data for the statistical analysis and so on. So the first part in a production pipeline would be the feature store. The second part is essentially applying server automation for every time we have a new feature or we have a new code. We want to essentially drive an automated flow for building the models or the different artifacts that are needed for the other steps. We're going to talk a lot about this component in a second. Once we build the models, we want to build a pipeline which holds the models, but the pipeline which holds the models is not just an endpoint. In many cases, it requires API integration. It requires transforming a JSON. It requires enriching data from the feature store, doing serving of one or more models. Maybe we want to apply a sort of ensemble, or maybe we have a model that needs some NLP to convert text to a sentiment, and then take that sentiment and drive it to a second model that does classification. And finally, when we have the results of the model, we also need to apply some action. So we need a real pipeline to handle our workloads. And then this pipeline also generates a lot of telemetry. We need that telemetry to be pushed to some analytics component that knows how to track the behavior of the model, identify drift, identify accuracy problems, anomalies, data quality problems, and so on. And also write all this data back into the feature store, so the next time we want to retrain the data, we have the insights from production, we have fresh data that we can train on, maybe even label that as it goes, and again, send alerts. So this is the operational pipeline that we want to drive. We also need to think about versioning. When we want to version something, we can't just version the model and version the data independently and version the training independently and so on. We have to think about sort of one version tag across all those components, because if I'm changing the data, probably I need to retrain the model, and I can't use the old model with new data and so on. So this is the operational pipeline, and this operational pipeline needs to talk to all the other things around it. So whether it's BI tools and data exploration tools, so to view and analyze the features for pre-production or post-production, manage notebooks, IDs, PyCharm, VS Code, and so on. Maybe there are great training frameworks out there or AutoML services that we want to leverage from our pipeline. CICD frameworks, Git, CI, and so on, and maybe other tools. So we need good integration between all those interactive tools or external services and the production pipeline. Okay, so essentially we want to transform the work that currently most people, the way that they work is this way. Someone is writing code, pushing it to some place, data scientist writes in Jupyter, then someone takes that code and starts transforming it into a container with YAML files for Kubernetes and so on, packages. So this is done by a separate guy, and then a third guy takes that and composes a pipeline from individual components, including the data preparation, etc., and runs that pipeline. And then yet another guy thinks about, okay, how am I going to monitor all those activities and essentially create a feedback loop? You can't really do that if you don't instrument all your components to work with the same metadata and data structures. So the alternative approach that we've taken with MLRun, which is an open source project, is to automate those flows. So we can take the code and turn that code automatically to an elastic, scalable microservice, essentially a serverless function. We're going to talk about it. Then we can take all those individual components and compose them into a flow, whether it's a batch or real-time flow. including the data engineering and so on. And because all those components come with built-in telemetry gathering, so it's codeless. You're just gonna get the monitoring out of the box without writing a single line of code. We're gonna see essentially how it's done. And this is from testimonials of people that are using it. We've seen that they're cutting their time to production by a magnitude. So how do we do all that magic? A lot of the magic is done through automation, through the notion of serverless function, of transforming code into Elastic services automatically. We're using several projects underneath the hood. Nucleo, which is also maintained by us, is more for the real-time and online use cases, as well as other serverless engines that are part of Amaran, for Spark, for Dust, and for different computation frameworks. So essentially, you can take a piece of code and just deploy that, and that will scale across multiple containers, manage itself, monitor itself, heal itself, and so on. How does it work? So essentially, if you think about my code is running inside some sort of a container that gets deployed automatically, or again, a set of containers, depending on the type of runtime. And this code automatically is sort of sandbox. So everything going in and out of that code, inputs, data, secrets, credentials, parameters going in, and things like logs, telemetry data, artifacts, and so on, going out, they're all logged automatically. So every time I'm running a job, I immediately see what was the input, what was the output. I can do lineage calculations. I can track the results, the artifacts, and so on. And again, it's also auto scaling. So if I have a workload that requires multiple containers, you can just scale it out across multiple containers. So this is the general idea of how those functions work. And if we take Amaran project, is essentially trying to focus on the 4 big pillars, the 4 things that make the life of productizing machine learning very, very hard. The first one is the feature engineering aspect using the Amaran feature store. Then we have the building of the real-time pipelines for the serving side and the real-time applications. We have all the closing the loops with the monitoring and retraining. And we have all the automation aspects, which we're gonna spend some time on in a minute, for applying CICD and integrating and creating sort of a managed workflow for deploying our artifacts to production. So we'll zoom in to each one of those. So the feature store, what is it really a feature store? We're gonna see that later in the demo, is the ability to take many different types of data, transform them into some meaningful features. Maybe it's categorical. We need to do one-off encoding. Maybe we need to map it to groups. Maybe we need to change dates to something else meaningful, like day of week. Maybe you need to do aggregates, joins, and so on. All those transformations could be described in a very high-level language, and that high-level language is compiled and transformed into serverless functions, and they can run in batch or real-time or both. So essentially, we build the pipeline, and that pipeline will allow us to work in production, in real-time, as well as in batch for training and other applications. All those features are getting cataloged, and then they could be served to many different applications, BI tools, notebooks as a pandas data frame. You can snapshot a feature and create a version of that and feed it to training. You could use model serving. The model analysis is using data from the feature store, like statistical variance of each feature and so on, and also writing back features into the feature store. So having a feature store is becoming something that most people acknowledge is sort of mandatory if you have a real production use cases, if you're building operational pipelines. Again, how does it work? You can build those pipelines through the SDK and just a set of transformations. The Amaran feature store is the only one that supports structured and unstructured data. So you can use operations for structured data, but also for textual data, for NLP. There are a bunch of use cases and examples for that. Visual data, images and so on. And also the most complicated is the composite one, which essentially knows how to handle textual, numerical, and visual all at once. Like a PDF document with picture is a great example of a composite solution. There was, by the way, a webinar by IHS who's using that for building composite analysis. So that was the feature story. The next component is the ability to build those real-time pipelines. So you can build a real-time pipeline that has many different steps. Like, for example, you get a request, and maybe you enrich that request. You take the customer ID, you bring all the customer vectors. Maybe you want to do some pre-processing, feed it into an ensemble, do post-processing, and so on. So you can describe that pipeline. This is essentially, you can see the documentation of MLRun. There's full example, but you can describe all this huge pipeline, few lines of Python, and then you could just test it, debug it in your own notebook or ID. When you feel it's ready, you can just say deploy. The other nice thing is once you've saved it, you can do the deploy as part of a CI process. You don't have to manually go and say deploy. You can say every time I change the code, I change something within the Github Actions or something like that, you could say go deploy every time I'm changing something in my pipeline. This will start rolling upgrades. You could even do canaries. So we're going to see how it all connects together. So this is the real-time pipeline. We talked about the model monitoring. Again, all those services carry telemetry, and it could be monitored. So now to the focus of the discussion is really on the CICD and the automation of pushing projects into production. So the flow usually is that every time we want to change code, or sometimes just parameters, not the code, or maybe we have fresh data snapshot because we want to run training every few days or every week with making sure that the models are up to date. So every time we have a change, we want to run a flow. And this is a simplistic flow. We want to run training, then we may want to run some testing on our training, validate that the model really behaves as expected. In some cases, we run optimization, reduction of features, Onyx, or applying different methodologies to make our model more efficient. We can also do other things in this space. We can also do testing for making sure our model is resilient. We can add different steps to that flow. And finally, the last step of the flow is deploying something and testing that. For example, deploying the model as an endpoint, verifying that it actually works with HTTP requests that are with the structure that we've wanted to be. So we want to essentially build this set of steps. It could also be a graph with branching and so on, like you see here. And we want to drive it from code changes, manual, run, data changes, and so on. So this is all supported through MLRun, which knows how to run those complex workflows. The complex workflows are composed of steps where every step is a function. It's sort of a serverless function or a microservice, or external microservice, like a cloud service. For example, you want to run SageMaker or Azure ML or something, you could just put a step that runs training on Azure ML or SageMaker or any other tool. You want to push something to Slack, no problem. So again, the first thing that it does, it allows you to build complex workflows out of those individual functions that you build. Now, you don't really need to build all those functions because MLRun comes with a marketplace of built-in functions for serving, for training, for data processing, and so on. The way that it runs the flow is actually supports different CI engine. It's not trying to reinvent the wheel. It supports Kubeflow, GitHub Actions, GitLab CI, Jenkins, and so on. So you can essentially run using all those tools that you're used to. Like if your organization is already bought into Jenkins as a workflow engine, you can just plug it in to your Jenkins scripts, and we've done it with a bunch of customers. If you're using GitHub Actions, there's documentation and examples exactly how to do it. Everything that you're doing as part of those pipelines is auto-tracked, auto-versioned. The data, the code, data lineage, the artifacts. And another cool thing, because those serverless functions by themselves are elastic, so each one of the steps in the pipeline can actually scale horizontally. If you need to do training on 20 containers with GPUs, then you just specify as part of the configuration, and it will auto scale to distribute your workload across multiple containers. And we mentioned the function marketplace. So this is essentially how we want to drive those workflows. How does it work? In MLRun, there is a concept of project. Again, there's documentation for all of those things. So you can create a project. The project consists of functions and artifacts and workflows and parameters and secret credentials and so on. This is an example of a simple project that uses a code in my repo, a library function. Hub is essentially marketplace function. Some static artifact as an input, and maybe a workflow file for running a workflow. So I can just define that in the SDK. That will generate essentially a YAML file that is stored in the root of my Git. So when I'm loading project in PyCharm or from Git, etc., this file allows me to essentially go and just run the project or do all sorts of things with that project. And then once I've built the project definitions, or could even manually just create the YAML file for it, then I could run those projects from everywhere I want. I can run the projects locally, or I can just even load the project from a Git repo locally, load all its objects, and just execute a workflow. This is an example using the SDK, or I can just use it a CLI command. Usually, when we're doing the integration with GitHub Actions or Jenkins, etc., it's essentially just saying, just run the CLI command, and it will trigger the workflow and run it for the CI. So again, it's very easy to go and take a project with comprised of multiple functions and data engineering aspects and models and so on, and then just sort of save it and then load it in another cluster or system directly from Git or a Git tag and run it. The other nice thing is that we're not trying to force you to use MLRun pipeline UI, which is very extensive and so on. You can actually see the progress of your pipeline almost on any tool. We know we have exporters that you can just, within your Jupyter, if you're running this workflow from Jupyter, there's a widget that it actually updates dynamically and will show you the progress of the pipeline and all the results directly on your notebook. If you're running the pipeline from GitHub or GitLab, it will essentially automatically integrate with the GitLab UI. It will throw back the results of the pipeline into the pull request comment, and we'll see that in a second. So we can track the version every time we run a job. We can see what were the result of that change of our code or the change of the data. If you're sort of a fan of Slack, it will just throw to Slack or Kubeflow, but also TensorBoard. I didn't mention it here. So it essentially exports the data to many different tools in parallel and allow you to use the tool of your choice. And if you want to integrate that into like an action, a Git action, like every time you do a pull request, you want to trigger that pipeline, then this is all documented. You can see that in the MLRun documentation. This is the GitHub action script, and this is GitLab script, and there's a Jenkins script. So you just need to, essentially what it does is only running the CLI command, which loads the Git clone and runs the workflow pipeline. It knows also automatically how to detect all the sort of the GitHub Actions or GitLab environment variables. To see here, you don't put any parameters. It essentially figures out all the parameters from the environment, parameters and secrets, and etc. So that's essentially loading and running a flow every time you do a Git action, like a pull request or a merge, or so on. The other thing is we've seen that all those functions, they generate lots of artifacts you see in charts, and they generate models and they register models. And you probably say to yourself, you know what, probably there's lots of instrumentation. I need to go and take my old code and change it and now start handling all those DevOps and MLOps activities of logging artifacts, data lineage, all the lists that you see here, applying auto scaling, supporting GPUs, doing checkpointing, and so on. No, the only thing you need to do is just add one line to your code. You just say apply MLRun. You give it the model. If you're sort of in a training job, you have all sorts of parameters you can apply here. even tell the system if you want to customize the artifacts it's generating. If you want TensorFlow to generate an Onyx model or a JSON model, you could say the format is Onyx. All of that stuff is going to happen automatically. The secret sauce is essentially once you give it the model and you do fit, it hooks on the fit on the other model activities, and like post fit, it will essentially log the model and log the matrix and so on. So there's a sort of it's doing a lot of other things, but this is just the general trick. By the way, it's open source. Everyone can just go and see how it's done in the code. But essentially, all those features of MLOps are applying by just adding a single line to your code. And then you're going to see all those artifacts and telemetry data and so on. Now, all those pipelines essentially are using those serverless engines that essentially do dynamic resource allocation, management, failover of those things. And you could just go to the user interface of MLRun and see, you could configure the elasticity, you can configure the resources, do I want GPUs and how many, how do I want to scale my workloads, like minimum and maximum thresholds. Every time you run, everything gets tracked, including versioning. You want to see the consumption of resources of jobs while they're running. You can just open Grafana dashboards for that. Even look at per project, per user, and do billing based on that, etc. So we've talked about all those things that lead to building those CI pipelines and etc. What happens in reality? It's not that we're just doing a pull request and something just goes on and deploys to production. No one really deploys to production from just doing a pull request. So this is an example that I leveraged some stuff from our customers that are already doing those things in production. This is an example of a flow, how to take code from development and be able to build a fully automated flow into production. Okay, and you have three colors here. One is sort of manual steps. The second one is things that run as part of your CI, your GitHub Actions or Jenkins and so on. And the blue is sort of the things that run on the Kubernetes cluster that runs those serverless engines, essentially the heavyweight computation. So what happens usually is someone creates a feature branch. You want to test a new change of your model, maybe test some different logic and so on. So you create a feature branch, and usually you will run interactively. You do some changes in the code and you submit a run. You don't want to do it automatically. And also the input data for that will probably be a CSV file or something relatively small, just to validate that you're not breaking any logic. So this will usually be the interactive development part. Once you finish the interactive development part, you want to merge your changes into a development branch. Okay, so you do a pull request, and then once you do the pull request, a bunch of static unit tests and things like that are running, like Black and like Flake 8, and all sorts of static analysis tools, verifying that all the imports are proper, everything is done correctly. Maybe running some unit tests for your code before doing something more extensive. And then you need a real cluster. You need now to scale. Maybe you need GPUs. Maybe you need and also you want to track every execution, just like we've seen. We want to track the experiments, track the accuracy of the models, log the models, and so on. So this is really where you plug this thing that I mentioned here. Those pipeline integrations that will essentially, every time you do the pull request, post testing, you do the automated flow for running the data preparation. This time on probably a much larger data set. Also the training, we may want to run the training now with hyperparameters, not just with simple parameters. We want to try different permutations. We want to deploy. We want to test the deployment, that it's really working and it's resilient. So we essentially build a pipeline that just this time could be the same pipeline, just this time feed from a different data source. Once we have that, we throw the results back into the CI system, just like I've shown a minute ago. And then a guy needs to say, you know what, that's cool, that's a great version. He needs to approve and merge it into the development. And once he approves it into development, maybe we even deploy it. We tag it and deploy it in development. So then we, different people can work on that on development, or we may run some bigger regression tests, periodic, like once a day or once every few days, or before we merge all the changes to a master branch. So this is the the development, the staging flow. Some companies have also integration test clusters and others. But once we finish the staging, now we want to move into production. So we need to take that development branch and merge it into the master branch. What we want to do after we merge it into a master branch, we want to validate everything against real business use case. And for example, maybe we build Canary, we deploy our new pipeline. It's not just deploying a model, because you understand that maybe the feature engineering code has changed as well. So we need to deploy a parallel pipeline that may work on just a subset, 10% of the customers, and measure that the business metrics are still maintained properly. Like, we're not losing money. This bot is not spitting out stupid sentences and so on. Once we've done that Canary deployment, we see everything is great. We've validated the business matrix. We want to approve that. When we approve that, essentially we create a release, we tag it, and we do a rolling upgrade of the system. So this is a complete flow, an example flow. Again, every organization will probably take it to his own sort of set of guidance. Obviously there are aspects of governance and that needs to be applied and so on. But this is just to give you a sense of how things could be built. So with that, let's look into some examples of how it's done in practice. Sorry, this is an example I'm going to show in a demo in a second of building a fraud application, fraud detection application. So we need that fraud application is essentially using 3 different data sets, some user activities, account data, like this user is sort of a male with this age and so on. It may have some account activities. Every time you swipe a credit card, it generates a transaction. You have activities like the user logged into his account, logged out of his account, etc. So we have many different data sets. Some of the data sets are batch, they're static, like user age doesn't change much, or gender in most cases doesn't change. And some things are periodic, once a day you change something, and some things are real time, like geolocation change, a transaction of buying something just happened, and so on. So we need to take all of those things. We don't get them as CSV files, or we need to listen on the production data and tap on that production data. And we feed that data into the feature store, essentially by applying, these are called in the feature store feature sets, which are things that listen on a source, or conduct a set of transformations, writing it into the feature store and indexing it into the feature store. Once it's in the feature store, we can just go and start doing some interactive exploration. We can go and apply an automated pipeline of, for example, optimizing the features, running AutoML, deploying the real-time pipeline to production, and so on. Once we deploy the real-time pipeline to production, it's essentially running those real-time serverless engines that build those set of transformation of the production application. They will interact with the feature store to grab and enrich data, and they also interact with the model monitoring that tracks the matrix of the model, the features, the data quality, and writes the results back into the feature store. So we can run retraining on the next loop. So this is an example I'm going to share in a second of a full application. Another example coming from deep learning, but it's also you can see that in the demos repo, is with deep learning. There are also other demos with NLP and others. So let's assume I have a factory that generates images, or images coming from cameras. We need to go and throw all of them into some sort of file system or a bucket, and maybe also a key value store. And then periodically we're going to run training. Now we want to run the training distributed using frameworks like Corvo across multiple containers, maybe GPUs, a combination of hyperparameters. So we build a workflow which runs the training, does validation and testing. Once we have a model, we may want to compress the model and optimize it using frameworks such as Onyx. And then we want to deploy. What do we deploy? It's not just deploying an endpoint, because in this application, the flow is sort of very comprehensive. You can, the flow, the real-time flow is essentially fetching the image URLs from Kafka and then going and fetching the image itself, and then doing some pre-processing on the image, like resizing the image, changing colors of the image, etc. Running classification, then maybe we need to write back mask data, etc. Then we may want to push results into a database. So this is a real-time pipeline. It doesn't only consist of serving. Someone needs to write all of those other steps. The nice thing with MLRun, you can actually build all that as part of a single graph, and you could also distribute it across multiple containers. Like this guy will run on one container with GPU, those three guys will run on a sort of the first container, and those will run on a last container. So you can distribute those steps across multiple containers, and it's using streaming in order to connect those containers to each other. So this is the next, the two examples. I'm not sure I'll show you the second one, but you can see it in the documentation. So first, you can just go to mlrun.org and check the documentation, the function marketplace, installation instructions, and so on. We can get you from Iguaz, if you want to play around with it, we can give you a free trial cluster. And all those things are documented here. All the things that I mentioned, including what I mentioned about project management, building workflows, integrating workflows into CI. We have information about the real-time pipelines with examples, information about the feature store. This is an example of composing a pipeline with AutoML and some build. So this is a pipeline which is essentially building a function, because it has dependencies and packages and so on. So it turns the function manifest into a real container function. Then I'm running, for example, this function which is doing some pre-processing. This is just an example. After running the build command, then it's running AutoML training, so I can even specify a set of algorithms that it's going to run, etc. So it's going to select some models off of the AutoML. I take those into a testing framework, so you can see the output of one step is feeding the next step. So the model that was generated on the training step is used as an input to the testing and as an input to the serving here. This one is deploying the serving function, and the last step here is essentially testing. Once the serving function was deployed, it's using HTTP requests to test, and using the test set data and essentially verifying that the model endpoint behaves as it should. So sometimes, we build a model, it works great offline or using an API, but when we try it out inside a container and behind an HTTP endpoint, suddenly we may be missing a package, or some data may be malformed, etc. So we want to verify the endpoint itself, not just the serving endpoint. So this is just as an example of a workflow. And running that workflow, again, it could be done through CLI command, or inside the CI system, or using the SDK. So that's just a generic example. The demo that I was talking about on the fraud detection. This is, let me maximize my screen. It will be clearer. So the way that we work, we have in this project, which is also documented under all this stuff is, if you go under feature store and end-to-end example, you have 3 notebooks here. One notebook for the data ingestion, a notebook showing the training, and one for serving, and the last one is really the automated end-to-end pipeline with sort of everything fully automated. But if we go to the first notebook of building those features using the feature store, essentially this part of the flow, let's assume I have all those swipe transactions, someone just swiping credit card information, and I need to be able to take that data and use it for training or for serving. Again, it's not necessarily a CSV file, it's data that keeps on feeding. I may have a CSV file as an example to just show me the data set so I can start training on it. But when I'm going to move my training to a production solution where the model gets retrained every day or every week, I need to automatically transform the data coming from Kafka into a Parquet file or a CSV file that will be used for serving. And in the serving, I want to take that real-time data and turn it into sort of a real real-time enrichment operation for transforming my user ID to a full vector of that user and be able to understand if this user is conducting fraud or not. So in order to do that, we need to build analytics pipeline. Usually it's a lot of work, but the nice thing with MLRun, it's not a lot of work. We can just build, this is, for example, a swipe transaction data sample. I think it's based on some Kaggle project. And we want to do all those manipulations to that input data. We want to extract the data, extract time information, like what was the hour, what is the day of the week, etc. Do all sorts of mappings, encodings, different aggregations over the sum of transactions, aggregation over the categories, how many shoes you're buying, how much food are you buying, and so on. And then we want to persist all that data. So we need to build a flow that does all of those things. This is essentially the flow that we're building. In order to build that flow, we don't need an army of data engineers. We just go and write the simple flow with all those operations that we just mentioned. And this is essentially building what this analytic pipelines for us. This analytic pipeline is used for real time and for batch. You don't need to do re-engineering. You just describe it once, you can visualize it, and we can move to the next data set. We can even visualize the result. You see, this is all those aggregations and testing. We want to change something in our logic. We go back to the code, we change it, we go back, visualize it. Again, we don't depend on the data engineers anymore to build features. Data engineers can do it, but also the data scientists could play around with it. And we're doing it across the different feature set. This is the second features of like account activities, logins, logouts, etc. There's another feature set of the labels data that actually tells us there is fraud. Again, there's some logic for creating that indication, that label. And once we've done it, we're done. Now, if we want to build real-time ingestion, we already created those objects called feature sets. They're essentially in the database. They could be materialized as YAML files if we use it in a CI. In order to deploy them as something that listens on Kafka or any other stream or HTTP and does this ingestion automatically, the only thing we need to do is deploy them as a real-time service. Essentially, we say, okay, we have a source. Our source is a stream. This is the path of the stream. Some other indications. Go deploy this feature set object, this pipeline that listens on that source. Just go deploy it as a service. This is where it's essentially just going to run, create real Nucleo serverless functions, which are again auto-scaling, elastic, that listen on the Kafka stream and transform the data and create features in two forms. One is sort of Parquet files that are sort of getting appended all the time. The other one is in a key value. So the features that are used for the serving part. So this is how we generated the features. The next thing that we want to do, we want to train based on that data. So we load our project. We don't need to reconfigure the project from scratch. Just load it from the database. We define the features that we need for our fraud analysis. We need all those transaction features with aggregates. We may need the event features. So we build a new feature vector that comprises of those features. We say we use another feature for the labels. So we train on getting that label value. And then we could just go and materialize that. Essentially, you think we had 3 different data sets, the swipe transactions, the static data, the label data, the account activities, all that, and we need to join them. We also need to join them based on point in time. So we need to make sure that when we join the transaction, we join it with the right label on the right timestamp. So all that stuff is happening behind the scenes. This is all using analytics logic. It can run on Spark or Dask or Pandas. It supports 3 different engines, and it will essentially go and do all those joins, as of joins, time traveling, and build the data set for training. So you see, this is the data set that includes all those aggregates and encodings and the labels eventually. So now that we have a set data set, we want to run a training. So you can just go and use a marketplace function, which is doing machine learning, scikit-learn classification. We feed it with different algorithms that we want to test, different parameters or even hyperparameters, and we just execute the training job. Later on, you'll see that in the pipeline, we're essentially going to stitch all of those individual components into one flow that runs in CI. But before we're running that, we'll probably do it step by step. We'll probably just run the training on CSV file or on data from the feature store. We play around with it, we change parameters, and then when we build the pipeline, we set it with a set of parameters. So we run the training. Now we have the training, but you know what? Maybe we don't really need all those. How many features we have here? 36 features. If we can settle for less features, then we can run the model faster. We may not need to do engineering too much. Makes everyone happy. So essentially, we can just load another marketplace function from MRun called feature selection, and tell her, you know what? Here, take this feature vector, build a new feature vector for me, which is reduced, which only contains the meaningful features. If it's not meaningful, just throw it away. So then essentially this function is going to run, and it's going to tell me that those 6 features, probably makes sense that the amount of transaction is the most meaningful. Those 6 features are the really interesting ones. I don't need 36 features. So essentially, this new function created a new feature vector, which is reduced from 36 features to 6. Now we're going to train the model again, the same function, use it just with a new feature vector, which is this reduced feature vector, and I'm going to generate a new model. Okay, so you see, you can build the pipelines. The reason I'm showing you that is to understand that the pipelines not necessarily just go train and test and that's it. Maybe I want to do feature selection. Maybe I want to do other things as part of that pipeline. The last step that I want to do is essentially deploy a serving function. So we can take a classifier function. We don't really have to build it, but just for sake of a demo, because the library, the marketplace contains already pre-baked serving functions for different frameworks. But if I want to customize my own function, I can just build a class that has a load and a predict, pretty much like KF serving or other frameworks. So she copies the same concept and the same API. So I can build a serving class with load and predict. In this one, I'm actually also doing some prints just for sake of showing how things work. And then I want to build a topology. I want to build a topology that will keep it simple. I'm not going to do pre-processing and other things. We can build a topology that has what we call a router. The router will intercept the event. It will be an ensemble router. So it essentially goes to 3 different models that we built, do average on the results, and then respond. But there's another magic that we need. We need to take the customer ID and we need to convert it into a full extended feature vector. So this is what we call an enrichment ensemble routing. So that ensemble routing class also accepts a feature vector URL. And one of the things about real-time aggregations and all of that, that in some cases you're going to get null values, because you're saying, I want to know the number of transactions in a given 1 hour. What happens if there was no transaction? You get null value on that feature. So in that case, my model won't behave that well. So I want to essentially substitute null values with, for example, the mean value of that feature. So that magic happens because the feature store doesn't only store the features, it also stores the statistical variables of every feature, like mean and standard deviation and histograms and so on. So we can take, when we build that request, essentially what will happen is the router is going to get the customer ID, is going to enrich it with all the feature vector aspects for that customer. It's going to impute, essentially replace null values with a mean in that case, going to throw it to different models, get the result, and respond. So I can also simulate the entire flow in my notebook, because I don't necessarily want to deploy all of that into production. I want to make sure that my flow works well. So I can just build what we call mock server. So it's a simulator of the online service. I can throw in some requests on customer ID and see that it's actually producing results. What it does, by the way, on the back end, it's essentially using a feature store method called get online feature service, which is essentially getting an endpoint for enriching our functions with the policy. And then every time I'm throwing the sample ID, I'm going to get the feature vector. But this is happening inside the enrichment router, so you don't need to do that. And when you want to deploy the model to production, you just essentially do function deploy, and it will deploy that serving function, not just serving function, this entire pipeline into production. And then we could go and even test the real live endpoint and verify that this model actually works. Now, after we've done this work on the feature engineering part, on the training part, and the serving part, we want to stitch it into a pipeline. So this is really where we have the pipeline notebook. Again, we can build load our project. We can register other functions if we want, or we can register parameters will be used across our project. And then this essentially creates a project specification. It sits in the repository itself. There is like the project YAML file you see here. The reason you have that file is that if you're loading from Git or using CLI, it essentially reads the file and rebuilds the project object off of that. And then if we want to just load it on a different cluster and run it, we just do load and run, or using the CLI, either using the SDK or the CLI. And what we have here is also a workflow. And again, if we're using GitHub Actions or Jenkins, etc., we just throw that line into our CI script. Now the workflow, and in this case, we're using the Kubeflow engine for running the workflow, is essentially running the feature selection to reduce the features, running the AutoML function, running the testing function, and then running the serving function. For creating the serving function and then deploying the serving function to production. So in this flow, I essentially did all the work of the feature selection, the training, and deployment of an endpoint. I could have continued here and doing the test deploy that I showed you before, and then just running this this flow. This one has an error. I need to fix it. Maybe I have something. This is another example. You can see when I'm running, it essentially interacts directly. I can see the progress of that flow as it runs. I rerun a flow, and you'll see that essentially it starts updating the picture as things starting to progress on the flow. If you have Kubeflow, you'll actually see that in Kubeflow, and also you will see everything in the MLRun UI. So you can see in the UI, it's much richer. You can see every job. You can see what were the inputs, what were the generated artifacts, the matrix results, logs, and so on for every one of those steps. Okay, and if we go into the project, we can look at the models that were generated. All those things were created automatically. I don't need to do anything. All this auto logging, all that is registered my models with all their matrix. If I want to see the model object, it's a very extensive object. It includes all the statistical analysis, the schema of the features, the matrix of the model, artifacts, etc. So it's not just saving a model, it's saving a model with lots of other things that when you're doing the model monitoring and model analysis, it essentially takes that metadata and compares it with other things. So again, this is, if I have a project, it contains those jobs and workflows. It also contains real-time functions that are all running under the same project. We go into the feature store. So all those, let's take another. So taking the fraud project, then we can see the features, this was the pipeline for the real-time transactions, the swipe transactions. We can see the features. We can preview the data. We can see the statistical analysis of every feature. And this feature set or these feature vectors, they're all objects. They all have URLs with versioning information that could be used inside the pipeline. If we just plug this as the data source for the training, the system will automatically materialize the data and with the right version and so on and use it for the training because it has like a special artifact URL. So this is so you see I ran this thing again, and again it regenerated the pipeline. In order for me to plug it into a CI, again it's a piece of cake. I just need to go and write the script inside GitHub or GitLab, and that will plug into it. So just as an example, this is a project demo that when I'm launching the project, when I'm doing a pull request, it will automatically start emitting messages telling me I'm running the project. And you can check the progress. It will hyperlink into the MLRun UI. And then when it finishes running this workflow, it will provide me a summary. The summary is built into the Git. So if someone is now going to do a review, he's going to say, you know what, the accuracy here is not good enough or whatever. And or you can go and zoom in and look at the actual, through the hyperlink, look at all the artifacts in the MLRun UI, and then take a decision if he wants to move to the next phase of deploying or just ditch this version, or just tell the guy go rerun the job with maybe different parameters. So this is how you can interact, and the only thing you need to do in this case in your project, in case of GitHub, is just have this YAML file. Essentially, it's the same YAML file that you just copy and put everywhere, which has passes the credentials. If I want integration with Slack, I pass the Slack web credentials, etc. And what it does essentially just running the main workflow in that project. And the same for GitHub or Jenkins. You can do it in any other framework. So with that, let's see if we have any questions or comments.